Alright guys, so let's have a look at what a beta positive particle radiation is. So basically, when we have beta positive decay or beta plus decay, what we get is we get a beta positive particle, which is a high speed positron. This is the antiparticle. This is an anti-electron. And we get a neutrino. Now remember, the neutrino is a massless particle, and its job is to conserve angular momentum. Now, over here, the mass of the beta positive particle is 5 times 10 to the minus 4 atomic mass units, and its speed is 20% the speed of light. So what is the change? Basically, you have a proton in this case converting to a neutron, and a positron, and a neutrino. So what will happen is the Z, or the atomic number, will decrease by 1. Okay, the atomic mass will stay the same. It does not change, and that's because the protons change to the neutrons. So it's, we've got the same mass, but the neutrons have gone up by 1, and the protons have gone down by 1. So the conditions that this occurs on is essentially the neutron to proton ratio is too low, or you have excess protons. It has medium penetrative power, which means it can be stopped by aluminium. It will go straight through paper, unlike an alpha particle, and this is because it's much, much smaller, so it's able to shoot straight on through. It has medium ionization potential, which is, so that's the ability of it to change an atom into something else, or ionize an atom. And it is deflected in EMF, which is electromagnetic fields. Now, this will be attracted to the negative plate. Okay, because it's a positive charge to be attracted to the negative plate. So let's have a little example. Here is nitrogen 13, so it's 13 over here. 7 is the proton number, obviously, or atomic number. We see that the neutrons to proton is too low. So we've actually got more protons than we do neutrons. So we go through this. The atomic mass stays 13. We now have 6 protons. Okay, 13 atomic mass. So we've gone from 7p, and that would be 6 neutrons, to 6 neutrons and 6 protons and 7 neutrons. And while we do this, it also releases the beta positive particle and the anti-neutrino. Sorry, no, the neutrino, not anti-neutrino. So the atomic mass stays the same, and Z decreases by, and that's where we're at. Thank you very much. See you next time. Any questions? Ask them in the comments below.